Obviously, I'm not Drew Barbier. My name is Jahur Vora. Drew couldn't make it this week, so I'm giving his presentation. So what do we do at SiFive? So SiFive, we are focused on two main businesses. We have an IP licensing business where we license our microprocessor IP, as well as SoC IP. So these would be things like interlocking, HBM, USB, along with Debug and Trace IP as well. Outside of that, the second business we focus on is our custom ASIC or custom SoC business. So this is where we engage with our customers and work with them to build custom silicon. So SiFive today is 600 people strong. We have 15 offices globally. So yeah, as I said, we are focused on CPUs, SoCs. We also have a portfolio of security IP. We have some demos here as well that you can come and check out. On the silicon side, we work with our customers either anywhere in between, from the specification all the way to test edge package parts. We engage with customers at RTL handoff or netlist or GDS2 handoff. We do package design, SoC validation, implementation, as well as production. From an ecosystem standpoint, as I said, we have CPUs that are based on RISC-V ISA, which is an open architecture. We are also heavily involved with open source projects like Chips Alliance, as well as an ecosystem of foundries that we engage with. So from a silicon side, we work with foundries like TSMC, Samsung, Global Foundries, and others. We work very closely with the EDA guys as well in terms of leveraging what they offer. On the silicon IP side, we have partnerships with a lot of IP vendors. So this is where customers come in and want to build custom SoCs. We work with them on specification, but we also source a lot of IP that is required for building custom SoCs. So focusing a bit more on our CPU IP portfolio. So at a high level, we have three classes of cores. We have the E-class CPUs, which are 32-bit embedded cores. We have our S cores, which are 64-bit embedded CPU. So this is something very unique that we offer, where you have a 64-bit core. So if somebody wants to do a 64-bit heterogeneous compute cluster, we can offer that today with an embedded core along with a Linux-capable U core. Our U cores are 64-bit application cores. And then if you look on the horizontal axis, we provide different microarchitectures that scales performance as well as power, depending on the application that the customer is trying to build. So on the area power efficient side, we have the 2 series. So these are either 2-stage or 3-stage pipeline CPUs. E2 series is our smallest core available today. And then from there, we essentially enable our customers to significantly customize our CPUs. One of the benefits of RISC-V ISA is that it's modular. And we enable our customers to realize that modularity through configuration options that we offer through SiFive Core Designer. We have the S2 series, that is our 64-bit core. So again, that is a 3-stage pipeline. It doubles the load store bandwidth. So from a per megahertz standpoint, you get higher performance than you would with an E2 series. As you work up in the middle here, we have our 3 and the 5 series. So these are slightly higher performant cores, deeper pipeline, so you can clock them at higher speeds. They also give you higher performance per megahertz. So if you look at our E3 series, essentially it's a 32-bit embedded core, but with the 3 series now we enable caches. So you have an instruction cache, you have a data cache. You also have the opportunity to build tightly integrated memories or TCMs or TIMs. So you have TIMs on the instruction side as well as the data side. On the 3 series, we also enable coherent multi-cluster implementations as well. So you can essentially have up to 8 cores in a single cluster. You have a coherent L1 memory system that is supported, coherence is supported in hardware. You can add a unified level 2 cache as well. The memory system can be significantly configured. So for instance, our L2 can behave as a scratchpad memory if you chose to, whereby it's memory mapped, it's a shared L2, it supports an accelerator coming in through the front port and can allocate into the L2. So it supports more deterministic performance with the L2 memory system. The S5 is essentially the same microarchitecture, but it's a 64-bit version of the E3 series. And then the U5 is our Linux-capable core. So it supports the RISC-V SV39MMU, supports the supervisor mode. Again, it's configurable. It's a multi-core. You can configure up to 9 cores. One of the unique ability we have is the core can be configured as a multi-core heterogeneous configuration. So you can combine the U5 with an S5 or a U5 with an E3. So you can have an SMP-capable Linux cluster with a real-time core, all working with a coherent level 1 memory system and a shared level 2. 7 series was something that we launched in 2018. So that's our 8-stage dual-issue superscalar core. With 7 series, you get about 50% more performance than the 5 series, but only at about 30% increase in area. Again, we offer all the 3 types in the 7 series as well. You have the embedded E7, and then you have the 64-bit embedded S7, as well as the U7 cores. The 7 series, again, has a very flexible memory system, just like the other cores. We also added a couple new features in the 7 series. So you have an ability to add a low latency peripheral port, or what we call our fast I/O port. And then this year we are working on our U8 series. So this is our first out-of-order superscalar CPU that is going to be available this year. So one of the other differentiators that we bring to the table is not only the CPU cores, but also debug and trace. Trace is an integral part of our IP deliverable, so it's highly configurable. You can essentially, in a multi-core cluster or a single-core CPU, select from a GUI whether you want instruction trace or not. Our trace encoder is based on the Nexus 5001 trace protocol, which is an IEEE standard. Our trace infrastructure is highly configurable, so you can essentially collect trace, and you can sync traces onto an on-chip buffer or an SRAM. You can also send trace through off-chip pins or trace into memory like a DDR. So it's a very flexible trace subsystem that we provide with our core. Again, multi-core capable, multi-core debug. So we support things like cross-triggering between multiple cores, so you can get a much synchronized debug experience with our trace IP. As I said, our trace IP is also compliant to CoreSite. We have customers who use an ARM core and a RISC-V core in the same SoC complex, and they want to make sure that the trace IP can plug and play with CoreSite IP, for instance. So we support CoreSite compatibility with our trace IP. Again, as you can see, so you can come in via a JTAG or a CoreSite APB. We have a debug module. The debug module also supports secure debug. So we have a authentication module that is part of our debug IP unit. So you can do an authenticated based debug experience with the RISC-V core. So from a security standpoint, we also have a highly differentiated security offering as part of our SoC IP and CPU IP, whereby we can support a secure lifecycle of an SoC, as well as secure communications. We're adding hooks into RTOS and operating system as well to support things like secure boot, for instance. We have hardware crypto accelerators as well that you can integrate next to the core to support secure boot as well as security implementations. We can support various threat models as well with our secure IP, and our security team is here as well, so you can come and talk to them as well. So coming back to Core Designer, I mean, one of the benefits of RISC-V is the modular instruction set, and the promise is, the idea with that is you can configure the extensions that you need and the modes that you need. And the way we make it easy for people to realize that is through SiFive Core Designer. So it's a web-based portal where somebody can come in, choose a microarchitecture that they want, and then configure the microarchitecture depending on the applications that they're developing. So for instance, in this case, you have the 7 series. You're starting out from an E7 class core. You can go and configure the number of cores that you want. As I said, we support up to 8 cores in a single cluster. You can configure the memory system around it. You can configure the associated and the caches, the size of the caches, as well as the size of the tightly integrated memories around the core. From a security standpoint, we support PMP, physical memory protection, on an MPU. So that's configurable as well. Depending on the application, you can configure in or out. From a debug standpoint, again, the trace IP is highly configurable, but also the number of debug resources within a core are configurable as well. So for instance, things like the number of breakpoint units that you want to support, it allows you to make those trade-offs through a GUI, whether you want to have up to 16 breakpoint units within the CPU. Interrupts are also configurable. You can configure the type of interrupt controller that you want in the core, the number of priority levels, the number of interrupts. So you're making those area performance trade-offs as well. And then we are doing a bunch of other things within our core that make SoC integration and integration with the EDA tools much easier. So things like DFT hooks in the CPU, power management. The branch prediction is also configurable as well within the CPUs. Once you configure the core, you get configured RTL. You get documentation that is also configured based on the memory map that you define with the core. Not only that, we also give you an SDK that matches the memory map that you've configured. It includes linker scripts. It includes a full SDK that allows you to start developing software from day one. You also get an FPGA bitstream. So this is, it allows you to download the bitstream on a low-cost FPGA, run benchmarks on day one, and it allows you to iterate when you are configuring the core to quickly analyze the performance that you may get from the different configurations that you built into the core. What good is a core without tools, right? So we provide a tool chain that is open source and free. So that's our Freedom tools. It includes a GCC compiler. It includes an OpenOCD GDB-based debugger, and it also includes a QEMU simulator that's integrated. So you can start developing software on a real board or an FPGA platform or on an ISS model. We've also developed an API called Freedom Metal. So the Freedom Metal API is portable, so you can develop for a specific RISC-V core for a specific series, and then you can essentially take that and run it on different RISC-V cores from SiFive. So that's a bare metal library that's available. And then Freedom SDK are basically a bunch of examples, build scripts, linker scripts, that allow you to retarget the code that you have written either on an FPGA platform or an RTL simulation environment. So that is also part of our deliverable. When you configure the core, you get the Freedom SDK that matches the configuration that you've configured. And then Freedom Studio is our IDE. So it's an Eclipse-based IDE that wraps everything together. So on the ecosystem side, we partner with a lot of ecosystem partners as well. As you can imagine, on the software tools and operating system side, we work with all the major tool vendors. Our trace IP is based on Nexus 5001 protocol, which has been supported already for a number of years by the bigger tool vendors like Lauterbach, for instance. We work with our modeling partners like Imperis. So customers needing performance models and ISS models, they have an ability to model RISC-V, SiFive implementations. Of course, we work with Sega and IR with their toolchain as well. They support all our RISC-V implementations today. From an IP standpoint, on the custom SoC side, we work with a number of IP vendors for DSPs, GPUs, I/O interfaces, PCI Express, things like that. So we have strong relationships with all those as part of our open silicon business, which has done about 300 tape-outs over the last 15 years. And as I said, on the foundry side, we work with a number of foundries. We're fab agnostic when we work and build custom silicon for our customers. Okay, that wraps up my presentation. I'll be happy to talk one-on-one if you have any questions. Thank you.